All right, let's go ahead and get this show on the road. First of all, thank you all for joining our second conversation on agentic AI and AppSec. I have a couple great panelists here with me. We'll do introductions in a second, but this is the second. We had one kind of kickoff conversation that was held with Stuart McClure, our CEO here at Quiet AI, and Ed Amoroso, industry veteran, talking about the impact of agentic AI in AppSec. And so this will be the second conversation. This one will probably get a little bit more technical, slightly more in the weeds, but not too deep. Maybe we'll save that for the third conversation. The idea is it's more podcast format. It's not going to be a whole bunch of slides that we're taking you through. It won't be a sales pitch or anything like that. We try to pick out topics that we think people care about and are curious about, and that's why we selected these two incredible panelists to have this conversation. So, with that being said, we'll go ahead and get started. I will kick things off with that introduction, and I'll pass the mic to these guys. So my name is Chris Hatter. I'm the Chief Operating Officer and CISO here at Quiet AI. I come from a background in cybersecurity. I actually worked with Tim for many, many years, where we were close partners in actually building the cybersecurity program at a company called Nielsen, which you may have heard of, does TV ratings. We both did that for a very, very long time. And I think we're both very proud of what we built and created there. So really happy to be back and talking to you, Tim. And so I'll pass it over to Chayton.
Awesome. Very good morning to you, Chris and Tim, and hello to all attending. My name is Chaitan Karnaki, CTO and founder at Quiet. Over to you, Tim.
Tim Chase, as Chris mentioned, he and I worked together at Nielsen for a while. Then I left there, and it was a CISO at a company called HealthStream. And now I'm do some consulting and application security work with continuous security.
Cool. All right. So just in terms of scope of the conversation, we're going to talk about agentic AI mostly. We'll start with why is that? What is it? Why does it matter? And how does it apply to AppSec? We'll talk a little bit about the current state of application security, and then we'll let the conversation flow from there into some deeper questions. But I do want to start there. So Chayton, Quiet as a company talks about agentic AI. Other people advertise it. A lot of companies are coming out to secure LLMs and AI. Can you talk about agentic AI? What is it? How is it different from a lot of what people are reading about in the market? And what are the different types of ways of interacting with LLMs? I want to start there, just set the groundwork before we dive into AppSec.
Perfect, Chris. It's a very resounding and relevant topic at this point. We're hearing agentic AI everywhere at this point, and mostly from the marketing perspective. But I'm going to go back a bit in history, trying to define what an agent is, so we understand, its relevance in the current world. Very quickly, we are at the second stage of the evolution of large language models. In the first stage, we encountered or we were introduced to a large language model, and our interface to interact with this large language model was asking questions and receiving answers. And this was a continuous and iterative process where, there was a degree of refinement where we ask the question, we sometimes get an accurate answer and not so much other times. Then we refine our question and we progress forwards. Over time, this use case became repetitive. So as naturally, innovation led to the fact that you try to bake in that refinement into this process so that you always get high signal from a response perspective. And now we are at somewhat the second stage of this evolution, where you endow an agent or scaffold an agent over the large language model. Again, this term is somewhat abused, from a marketing standpoint. If something catches fire, you want to use that term parsimoniously. So you land up defining or creating your own representation of an agent. But let me kind of define it from what cybernetics called agents. An agent is an artificial system interacting with the environment continuously without human assistance in order to carry out a task. That's a very simple definition. And many domains now have tasks to fulfill the needs of the persona utilizing this particular agent like a tool. So we are seeing different incarnations of that, which is, somewhat autonomous, semi-autonomous. But in summary, the agent is scaffolding the large language model, taking ownership of the task, doing this continuous refinement, owning a role, and providing value to the customer.
Okay, cool. So the second thing I just want to set the table on is where are we at from an AppSec standpoint? I'm going to go to you on this one, Tim. What does the AppSec market look like? How has it evolved? And where is AI starting to fit? I think we're all seeing and feeling it start to fit in. But what's your view on the market and how AI is going to play a role?
I think that the application security market has in the past lagged, I think, with taking advantage of some of the LLM. Quiet's one of the ones that's, I would say, ahead of the game. But, typically when you look at the application security space as a whole, they're still using a rules-based scanning engine. A lot of the folks in the market still want to say, if we see this in the code, then look at this. And the rules can be more sophisticated, and they can be tuned and tweaked and all of that. But when you look at a lot of the players that are there, that it's still very much a kind of a, if you see this, then flag it. If you see this, then flag it. And it's been that way for a while, and I think that it's really ready for a change. I'm seeing AI start to get into application security, specifically with being able to analyze, generate code for sure, but being able to analyze code and then write code for you. Just kind of as an example of one of the areas that I've used it recently is for a course I was developing. I had to write a shell script, and there were some errors in my shell script, some syntax errors that it was throwing up. And so I had a AI agent beside me, and I said, "What is wrong with this?" And they said, "Here's how you fix it, and here's why it's wrong. Click this to fix," right? And that's kind of the prompt-based AI that we were talking about earlier. And that's kind of, I think, where a lot of the market currently is at the moment, is still kind of the prompt-based for I think several reasons. One is I don't know that we've totally trust all of the input that the LLMs are giving us. I think to some extent we still want that human intervention to be like, yeah, I trust that change, or no, I don't want to do it that way. And I think that's still kind of the big one where we haven't quite turned there on a broad scale in the application security space.
Yeah, all good points. I think I'll just add my 2 cents to that. The driving force for me, even joining Quiet and going on this journey with Chayton and the team, is if you look at the AppSec market, you look at the tooling, and then you take a minute and you look at your own internal vulnerability statistics. I was just talking to a CISO this week, and we were talking about how most organizations' vulnerability counts in AppSec look like a S&P 500 graph, right? It starts low and left, and it goes up forever, up and right, right? And the problem that has plagued the entire industry for so long is that millions of dollars have been spent in this arena by many companies. A lot of efforts have gone into it, a lot of time spent, and we haven't been able to bend that curve and start bringing those vulnerabilities down in any meaningful way. We just get better at finding more. And that's not a very sustainable future, particularly because developers themselves today, I think, are going to become more productive by having, AI co-pilots sitting next to them. They're going to write more code themselves. The second thing that I'm seeing happening right now is that not only are developers becoming more productive, we're seeing people that don't sit under a CTO now having the ability to maybe not build enterprise grade applications, but using LLMs and AI to create code, to create utilities and applications that help them better in their day to day. What happens to the AppSec team at that point? I've never met anyone that raise their hand and is like, we're fully staffed. We feel really good about where we're at. We could scale to all the developers at our organization, both from a people and tooling perspective. Now they just have more code from those devs, and now new people entering the fray, adding code into the mix. So the surface of what needs to be secured in code is growing, and it's growing pretty rapidly. And so I've yet to come up with a better idea than applying AI to the problem. And certainly what I see in the market is Quiet is not the only ones doing this for sure. I mean, I think you'll see us, and you'll see all of our our competitors really investing in the space because we have to bend the curve together, right? All of us that are involved in the application security game, we have to bend that curve, give people the ability to actually fix their problems instead of just producing more and more vulnerabilities that they can't get to anyways. And so that's my hope as an industry, that we are able to do that. I feel very strongly that we are all, collectively on the right path. Of course, I'm biased when I say I think Quiet's on the best path, but I do think that we're heading in a direction that is actually and finally going to put tooling not only in AppSec's hands, but also developers' hands that allow us to bend that curve and get focused. Okay, so Chayton, I'm going to go back to you here. We talked about the AppSec market, did some definition on AI and agentic AI. Everybody knows, anyone who spent any time with large language models, they're not a silver bullet, just like everything else in our industry. What types of challenges, and maybe you could even tell our story of releasing an autofix product and kind of where we started from an engineering standpoint, what led us to go to the agentic approach, and what did we struggle with in terms of what the LLM performance is, perhaps?
Perfect. The excellent question, Chris. I'll sort of try to break this down into few parts. First, let's start with the large language model in itself. In the first generation of large language models or transformers, they were both encoding and decoding text, which is just the starting point of linguistics. And in the second generation, that corpus of information became code, because the what is interesting about code is that the grammar is limited. You're dealing with an abstract syntax of a particular programming language that is defined in a rigorous taxonomy and constraint. So when you process that, you're most likely going to get more accurate completion, which is why the use case of large language models in programming and source code is exploding more than linguistics. But let's come to the problem at hand, right? When this explosion happens, suddenly the transformer or the large language model becomes a sledgehammer. Every Tom, Dick, and Harry in a garage to a large enterprise wants to leverage the large language model to solve all sorts of problems. But let's bring down and focus on security as the core focus. For security, the corpus of information or the input is your existing code, albeit legacy or modern microservices. You might just literally take that entire corpus, feed it to a large language model, because today, context windows are substantially large, and then ask a broad question saying, needle in the haystack, just find me all these vulnerable conditions that might exist in the code. That's one use case. The other is you might land up getting few vulnerabilities. It might discover and do an effective job in extracting these vulnerabilities. And your next follow-up question is, can you suggest fixes? And of course, the large language model can suggest great fixes sometime, but most of the time it lands up making up stuff, hallucinating. I will not consider hallucination as bad. Often marketing likes to say this is nuts and this is really bad. If you have an LLM that's hallucinating, bad things are going to happen. Hallucination is good. All of us as humans hallucinate. That's when we get creative. And large language models are designed to hallucinate, because when you train a transformer model, you're feeding it different domains knowledge. And as different domains knowledge tend to actually cohere together, it begins to reason creatively. And that in turn is called or considered as hallucination. Sometimes it has negative effects. When you feed code, like we said, you've discovered a vulnerability and then you say, suggest a fix, it makes up a library and says, hey, here's a great fix. Use this library, sanitize using this library, or, authenticate using this library. And under the hood, if you're paying careful attention, it would have just manufactured this library out of thin air. It might not exist. And now if you're a careful observer, like a caretaker of the LLM, you say, hey, this is just completely made up. Go back and do your job again. But if you're not paying careful attention, then you might land up just importing that library And even worse, if an attacker did a good job in conducting trial and errors and training across the large diaspora of LLMs, they might take that manufactured name, hypo squat by creating it in the ecosystem, planting a backdoor. So now, if you as a consumer just pick up that library without paying that careful attention, you have pretty much inherited a backdoor. So this is a plaguing problem right now. And rather than painting, a doomsday scenario, what we do is we endow that problem to an agent. We in our world we call agents as rational agents, because these agents are just not task monkeys. They're just not executing based on your instructions. These agents do some degree of rational reasoning. When you ask it to do something, it figures out what it needs to do. It verifies what it does. If it's not good enough, it gets that information from another source and reinitiates the process again. So this is a problem that we're seeing, and we've managed to endow a rational agent to solve the problem.
Yeah, it makes sense. I mean, just to add more, just to kind of like fill in the picture here, when it comes to Quiet and our journey, when we were doing R&D on building AutoFix technology, we actually didn't start with the agentic approach. The issues that Chait was describing was what led us there. When we were just kind of testing around, stuffing LLMs full of source code, we ran into all these types of problems that we knew ultimately when getting to someone like Tim and saying, hey, I want your AppSec team and your developers to adopt this, the word hallucination would be very concerning, especially at the enterprise. And so we went on that journey of using agents of try to solve these very specific problems. The number one priority for us in the back of our mind is, if we sat here, the three of us, and we were presented with a vulnerability on the table in front of us, how would we go about solving it? Well, we would think through the problem and ultimately come out with a fix. We would say, Tim is the analyst. He looks at the vulnerability. He needs to determine, does it matter for my organization? What compensating controls exist to help me prevent that vulnerability from being exploited? Are there threat actors who are interested in my organization? What types of payloads are they using to exploit it? Think through all these things, prioritize, hand it to a developer. In this case, Tim, analyst agent, passes it to, Chaitin, developer agent. Chaitin takes the context from Tim, basically reasons with it, defines a code patch, right? And that code patch, what do people do? Like, obviously, we write the code. You have to get it verified. You got to run a unit test case. We are trying to subsume all of that complexity on behalf of the organization that we work with. And so the development is done by the agent, the testing and the examination of the effectiveness of the code patch is done by the agent, and ultimately it results in a high quality fix. Now, I wanted to go to you, Tim, on Chaitin talked about challenges with AI more specifically. I want to go to you and talk about how enterprises, how security teams, CISOs are thinking about investing in AI, bringing LLMs into their organization. I think there's a lot of camps here. I think on one hand, people are a bit nervous about that, and there's a lot of red tape that needs to happen before you could actually bring this in. But what are you seeing, and what are the concerns you would have about what we're talking about today and bringing that into your organization?
I mean, I think I kind of go back to our cloud days, right? I remember when organizations were going to the cloud, right? And you smile because you remember very well the AWS versus Azure arguments that we had, right? Not you and I, but in general. And
maybe you and I don't know, maybe.
I don't know. Could have been. We're still friends, so it ended up okay. But it went from let's look at it to we're going to do this, right? And we didn't have much of a choice because the business had made up their decision. It wasn't, they didn't come to you, they didn't come to me and say, should we go to the cloud, Chris? They were like, no, we're going to do this because we want to get out of our data centers and go to the cloud. And so we had to come up with the security context around it. And so that's what I'm seeing kind of in the business, right? It's everybody wants to use it. I've even seen, small companies, with 400 people that want to do AI stuff. So everybody wants to use it. And so we can't be like the sticks in the mud as CISOs and as security leaders and say, hang on, let's get all of our ducks in a row first, and then we can use it, because then that leads to shadow IT, shadow AI, I guess you could call it, or whatever, right? And so what I'm seeing CISOs want to do is put some rigor around it, right? They want to know, okay, where are we using AI? Which models are we using? And be able to track that to understand what are the risks with each model? How many models am I using? And then maybe even this isn't necessarily a security function per se, but kind of the additional benefit is, if I'm going to use a model for this part of the business, which one of these that I've already approved should we use, right? So kind of keeping an AI inventory model, which, a lot of security gets back to inventory. What do you have? And so I think that the security teams are really focused at the moment on the visibility. What do we have? What kind of AI models are we using? So I have not found uh, people in security and CISOs are afraid of using AI in security. I think they're still struggling to kind of find that value and then just know, all right, exactly how are we going to use it, so I can get a handle on it and make sure that, especially as it connects to data, right? Everything always comes back to data, and they want to know what data sets is it connecting to, how broadly is that data set going to be accessed, and that's really where I'm seeing it right now. That's kind of non-AppSec specific, but just security in general.
No, you're right. I think all good points. The way I laughed, when you started talking about cloud and how you have a similar feeling to that kind of transformation. I feel very much the same, that we're in that type of situation, because I recall those days when we were looking at moving massive amounts of workloads to public cloud, and the initial, I think, reaction from many people in security, outside of security, was, well, the cloud can't be secure. It just can't be secure, right? Th- Everything evolved to, well, it could probably be more secure, to, well, it's definitely more secure and it helps the business. Like, there was this kind of, I don't know what it's called, but like this acceptance loop where it was kind of scary and we ultimately got there. I think the innovation in AI and LLMs is just too strong of a business case to ignore it or be overly concerned about it. And so I talk to CISOs a lot about that. It's like it's inevitably going to happen. Everyone is right in putting the right guardrails in place to make sure that their organization's data is safe, and it can be effectively adopted. But I feel very much the same, in the sense that I think this started with a lot of concern, even so much as organizations blocking, things like ChatGPT and blocking
Right.
other types of AI models, to in the AppSec space, at least seeing a willingness to certainly adopt it. And I think it's going to become table stakes in our market. So all good points. I want to ask Chaitan now, in AppSec, like, why is code and AI, specifically LLMs, why is that a good marriage compared to the rest of use cases that are out there? And then I'm going to come back to agentic workflows here. Why is code and LLMs a good marriage?
Uh, that's an awesome question. When we actually initiated this podcast and webinar, right, we touched on the topic of linguistics. Um, Large language models are great at completing. They use something called as an autoregressive model, or a method where it helps you complete your sentence given the context a priori. But when you speak of linguistics, right, there are many types of languages, and then you have grammar, which is your typical I would say dictionary, and then that dictionary is further expanded with metaphors, and things get complicated. But when you're dealing with programming languages, you have different types of programming languages, and there's something called as abstract syntax, where syntactically that grammar is defined, which is how compilers work, where as you write code, it is measuring or evaluating your code against that grammar for the sanctity. And if you are essentially misappropriating, or you have committed some sort of syntactic error, the compiler will fail, and it gives you the appropriate message to correct so that you adhere to the grammar. For large language models, this is a sort of blessing, because you prime the model during training with the grammar. And now you train the model in an effective way to reason of what the programming construct is, how to effectively complete. And now when you serve up sufficient amount of training data by taking lots of public repositories and code that has been created in the open source ecosystem, its reasoning exponentially increases. It does a better job at this, which is why, if you round this up, programming or using large language models for code generation is exploding as a category compared to the prior, where you have those that are leveraging models to write books and so on and so forth. That's one point. And I want to bring it back to what else can be done with source code. You touched on this point earlier, and I forgot to mention it. If, say, you take a large corpus of source code and serve it to the LLM and ask the LLM, discover and help me find vulnerabilities, that's a different sort of reasoning compared to completing code. And I want to use a metaphor to explain this, right? Take, for instance, you go to IKEA, you buy a dining table, you go and pick up your box, you come home and you open it and you realize that you don't have the manual. Now you're scratching your head because, either you're going to go return that item or you say, I'm just going to go through trial and error, pick up the pieces, just keep assembling. Something doesn't work, I'll start from scratch. Your brain is almost working like a small child going through that process. And that's how the LLM is reasoning when you just serve up a large corp of code. It's almost saying, I don't have the manual, just go figure and let me know what the vulnerability is or where it lies. In our case, the code property graph, which we invented predating the large language model, is like that manual. It's like that instruction set saying, we have examined your code and there are all these pathways in your code. There might be potential conditions on these pathways that could lead to a vulnerability. Now, when you serve up the manual to the large language model with the code and you ask a question, the autoencoder is smart enough to look up the code property graph, pull up the context, and then give you the appropriate answer.
So I like that. I like that because I think that's solving one of the key problems, right? Like when you go back to the traditional static analysis, it's not smart enough to know if something is exercisable or not, right? But going back to the graph, right, and being able to understand that's one of the key advantages, I think, of kind of this method of application security, and it's able to solve it, earlier than runtime, or it's able to solve it kind of at the development stage, which is one of the keys. So that's one of the things I am excited about too. I like the way you describe that.
Yeah, and it's actually been obviously critically important in how we're developing fixed solutions, right? Because it has an incredible amount of context when you think about what the LLMs need to be successful, is it needs as much context as we can possibly fit in the window, right? And so it's been immensely helpful for us, not only in detecting vulnerabilities and doing that in a very creative way that's highly accurate, but also producing really high quality fixes. Tim, back to you on this one. Today, a lot of what's happening in the AppSec world around LLMs is code patching, code fixing. What other types of support or help do application security teams need that could be done by these types of agents? And it could be from basically anything under the AppSec umbrella, as far left as threat modeling, and as far right is actually like fixing the vulnerability. So like think a little bit about what are those types of use cases that you running a team would want to, if you could hire a fleet of agents, what would they work on?
Yeah, good question. There's a couple that come to mind right away. One is kind of what I mentioned earlier. We're going to start all the way at the left. It's providing the guidance to the developers, right? When you're sitting there in VS Code, having the AI agent or the AI tool that can sit there beside you and be able to give you explanations of why something is good or why something is bad. Be able just to kind of say, is this code efficient? Is this code, am I going to have a cross-site scripting on this code? Being able to just have that at their fingertips, I think is number one, because one of the hardest problems in our space is always education, right? That's why we're still talking about SQL injection, and I've been talking about it for 20 years. It still happens, right? And so I think as far left as that is still very important. And then the other thing that I would love to see from AI, and I don't think we're there yet, but I think this is probably where we're going to be able to go, kind of with the agentic approach, right? if you think about the natural evolution of testing, AppSec testing, when I started, it was manual, right? You were sitting there with just a proxy, and you were injecting requests, and you were seeing what you could get it to do. And then before long, you have two other tools that have come along that will scan the code base, and it will give you, 1,250 possible vulnerabilities in your code base. So, and then DevSecOps came along, and that provided some automation where you can hook into your Jenkins, your Circle CI, and really run this entire pipeline for all of your application security tools. And what I would like to see, is kind of the next evolution of that with the agentic approach to AppSec, which is, as opposed to having to have Jenkins run all of this kind of stuff, what if we could take it to the next step where you've got this agent, and this agent knows all the tools inside of your tool set, and it can run it, and it can scan it. If there's any, you can set I'm just going to give some examples, but you could configure, if you see any criticals, go ahead and propose an auto fix. And then if it meets certain criteria, you could then fix it before moving on, rerun the scan, right? And that's a little bit easier to say. There's probably some things in there where you'd want to check it against a couple of LLMs. So you'd want to make sure that maybe you have an approval process integrated into Slack where, hey, we found this. Are you okay with this type of scenario? But ultimately, I think you could drive a lot of your AppSec process through that agentic approach, where you've connected to multiple LLMs and you have it running all the tools in your tool set. And ultimately, I think it gets to your point at the very beginning, Chris, which is reducing those vulnerabilities, right? Because that goes with AppSec, that's with vulnerabilities that are on servers and open source library, like all of that. We're just overwhelmed to the point where it's kind of, we've got some stagnation that's happening, right, on a lot of teams. And so being able to reduce that, I think, is the ultimate approach, being able to have to do some sort of auto fix or reduce the time with these fixes. So that's kind of, where I would love to see it. If I were going to bring it in and bring a solution, I would love to see the security teams be able to do that and bring about the next phase of DevSecOps. I don't know if you'll even call it DevSecOps anymore. Maybe it's AI SecOps. Maybe we can term something new.
Yeah, to put my 2 cents in the mix here, the challenges that I felt that I faced running AppSec functions, it was always a tooling challenge, right? We always had to contend with false positives. We always had to contend with false negatives. We never had enough security analysts that can pour through the information and give high fidelity data to engineers, right? And so inevitably what happens is you have two choices. One is you sit on vulnerabilities until you can pour through them and add requisite context to give the developer. Or what happens, I think, most frequently is an arbitrary line is drawn that says anything that's high and critical, you throw it over the fence and you ask developers to work on it. And 9.9 times out of 10, that really doesn't work because it's not a high fidelity finding. There's a lot of false positives. And what you do is you pass the buck to the engineering team to actually figure that out. They have to go figure it out for themselves, which is never a good model. It's wasteful. Those engineers could be working on building products for your company, helping build revenue, doing all the things that they're assigned and incentivized to do, right? So my end game, I think, with application security and agentic AI is how do we deliver to the security leaders, the security teams, the AppSec teams, the amount of staffing that they feel is necessary to give incredibly high context requirements to engineering teams. So that's one bit of it. The second bit of it is the tools must improve to the point where they're not so inaccurate. We think AI can make a meaningful difference there. And when you combine those two things, you start to see a future where you could take the vulnerability curve and start bending it down, right? And so if I dive in a little bit more on agents and staff augmentation, like I do envision a world where application security teams, the humans are not being replaced, but similarly to how co-pilots are augmenting developers, we are augmenting the application security teams, the analysts, right, to be able to scale to the challenge that they have. They're often outnumbered 1,000 to 1 by developers, right? And so I would envision the world where these agents are doing that triage, right? They're understanding in detail the vulnerability. They're burning down all the false positives and getting them out of the way, right? They are providing not only what is the vulnerability in the code, they're helping the developer understand what went wrong and why, not using a generic training example, but this is your code that you wrote. This is the vulnerability, this is why, and here's how I can help you never write the vulnerability again. So on the fly, BAU, the agents are training the devs, right? That will hopefully prevent new vulnerabilities from being written in the future. At the same time, they are writing code fixes, code patches that are of high fidelity that can be relied upon. I think we're a ways away from blindly, pushing code that's AI generated into production. I think we're a long way from that, but you could get them 90% of the way there by explaining what is the vulnerability, how did I fix it, getting specific about all the steps that I took and all the work that the agents did to create the fix, and making sure it's of high fidelity. What does that mean for the people? The people in AppSec stop doing false positive identification. They stop having to try to explain what the vulnerability is. This is all offloaded to a team of AI agents that are working 24/7. Now, the application security engineer is starting to do higher order tasks. They're doing the threat modeling, and they might be using AI in some capacity to help them with that. They are doing penetration testing. They're engaging with the business about design patterns, right? Those things are what we all know and would want to do in application security that there's often not enough time to do, right? So that's my hope of where we go. But Jade, I'd like to hear your opinion as a developer. What do you want from security to deliver to you from any type of agentic approach?
You touched on many excellent points, and I'm going to sort of cue in on some of those points, right? You spoke of bending the vulnerability curve. That's an awesome slug, and I'm going to steal it from you. It's really cool. The second aspect is, um, can an agent be intelligent enough to augment a human or replace a human? This is a very controversial topic. But if we have to start, right, I'm going to start with, do not trust memes on Twitter, because anytime a product is released, there's always a set of influencers who go out there and say my socks is blown because this thing can just like magic generate code. Now that fits really well into a tweet, but let's transfer that into the real world. Does not work, period. It just does not work, because an agent has to be rational enough to autonomously function and operate. And we're still not there. And if I have to quickly draw a parallel, right, if you go back to Darwinian evolution on time scale of a human, we essentially start with what they call as bipedalism, our ability to walk on two legs or crawl. And then we move to dexterity, which is our ability to pick up things and reason and understand what it means and how they connect. And then we come to reasoning and consolidation, which is our ability to say, I'm not going to go touch a hot pan because I'm going to burn my hands. And with the advent of large language models, it started with reasoning. It's from the other side. And then at some point they realized, oh, you just can't reason without dexterity. So they introduced the concept of tools and function calling and gave it some reasoning there. Of course, large language models can't walk, so let's park the bipedalism aspect of it. But where I'm getting at with this is, when you endow an agent, right, and ask it to be rational, you still need the human guiding the agent, because we as humans possess something called as tacit knowledge. It's knowledge that is not explicated. Sometimes we're good at writing and representing, taxonomies, theories. It transfers over, becomes expertise that someone else can inherit. Other times we have skills that we don't know how to represent on paper. And that is still missing, which is why the human has to continue to interact with these rational agents. And the agent should have capacity to capture different modalities, meaning I might be good at speaking, bad at writing. So if I have an agent that is listening to me via speech and observing via vision, then all three modalities are capturing that intelligence and explicating that. So I feel like we are somewhat scratching the surface. We are getting there, but still, right, if I have to close out the argument, I'd say don't buy into memes and very quick marketing messages. If someone says something, apply it to your domain and see whether it works or not.
But I think ultimately the goal is similar to what I would say it's from DevSecOps. It's not to eliminate the AppSec function, the AppSec engineer, or anything like that. It's I've always looked at it as I want to take them away from being doers and make them more auditors, right? Because if you've we're, I think Chris said at the beginning, like we're only growing in the number of applications that we have. Like we're getting larger and larger applications. We're putting more and more data out there, and so the AppSec engineers are getting overloaded. So it's not that we want to just take all of this and put it over here and not deal with it anymore. I think it's kind of the same object that we had like with the security champion program, right? The idea behind the security champion program is to take some of the duties and the responsibilities of the application security engineer and give them to somebody on the DevOps team to make sure that they've got their ear to the ground and that they're doing the functions that you would want to do earlier, right? And I think this is going to be kind of the same thing. You want to basically, these security engineers, we want to give them tools that they can use to make sure the work is still getting done. But it's really just to help them or to augment what they're doing to help them scale, which is what it's all about. I think that's the way that I look at it.
And Chris, I want to add one more point on the closing, right?
Oh,
Which
please.
is I said that I really like that term, bending the vulnerability curve. And when I spoke of evolution, the last stage is perception, which is your ability to sense make in the environment. You can only bend the vulnerability curve as an agent if you have context of the surrounding environment. For example, if you detect a vulnerability, you have to understand where that application is deployed. Is it deployed 10 steps or one step away from the internet gateway? And further on, you have to perceive to understand what are the imminent threats currently trending. Now, each of these elements adds to the perception. And when they all consolidate together, you're reasoning, you're rationally saying, this is important, go solve it. The rest can wait.
Perfect. Okay, so I'll add one more, I think, question, but we'll make it rapid fire. We have some questions coming in. Please keep them rolling here. The kind of closing question that I have to both of you is when are we going to live in this world that we described, right? I think in the market today, we're at a point where we're augmenting a function of a team, not augmenting the whole team. When are we going to get there? Tim, I'll start with you.
I think if I put my futuristic hat on, I think this is 2025 will be the year of us kind of stretching there and still figuring out what works and what doesn't. And I think within the next 2 years, I think we're going to get to a um, uh, more intelligent application security agentic approach, right? Like if you look at the history so far, over the last 2 years, we've really seen the explosion. It was holy crap, these things are amazing. We're going to start building up data centers full of GPUs. And then it was, okay, what do we do with it? Oh, hey, agent or chatbots are really good. And then we're going to kind of see the evolution of that. And so I think that within the next 2 years, if I'm saying 2026, 2025 will be kind of the year of really starting to bend that curve.
Peyton?
I'm going to lean on Demis Hassabis, who's the chief head of DeepMind. He postulated that we are approximately about 10 years away from AGI. And rationality and AGI are somewhat synonymous to each other, which is the ability to completely replace human function. And for that, between now and maybe a decade or less than a decade, we need two more trigger innovations to kick in, where um, the agent is actually able to reason. The agent is actually able to capture some of the knowledge of you and me that is yet to be explicated. So I feel like, approximately 7 to 10 years away.
All right, that's a big difference. I think I on the side of sooner. Um, I think we'll get to the world that I described, where we have application security teams and developers doing higher order work next year, in a very, very meaningful way. I'm very impressed with how our industry is rallying around AutoFix. You wouldn't believe, if you haven't already looked at this technology, you should. It's incredible to see how quickly AutoFix for code security became a must-have, right? I won't even rewind a year, but it was somewhat of an afterthought at that point. It was still strictly like, I need SAST, SCA, SBOM, container, I need reachability, exploitability, I need all these things that are more traditional. It went from that to, we're not going to have a discussion unless AutoFix is involved, very, very fast, right? And so, um, people were kind of like messing around with it, um, within like the middle point of that. Now it's just every single engagement that we're doing has an auto fix element, as I think that the practitioners see a very different world that they can live in as long as this technology evolves, and as long as us on the vendor side can hold up our end of the bargain. We're going to live in a very different world for both AppSec and developers. And yeah, I think we will be able to bend that vulnerability curve in a meaningful way. I'm going to get to questions. I think that a couple of these questions so far are probably more geared to Chaitin, because they're asking specifically about quiet to a certain degree. So I'll start with the first one. How does your multi-agent AI system ensure vulnerability fixes it suggests are explainable to developers? So it's basically a question around trust, right? So why should a developer take a code patch, a code fix suggestion, and actually trust it?
That's an excellent question. Uh, Typically trust and explainability is both subjective rather than objective in nature. And the two issues here is, from the subjective standpoint, you have an expectation, and the system should match your expectation. The other is with large language models, they are non-deterministic in nature. Assume you ask the same question twice, you might get two different answers. So the goal is the following, right? If you have multiple agents cohering to solve your problem, you should capture the reasoning that led to each of their, outcomes that they've generated, that composes together to the final outcome. So in our case, what we do is we capture the reasoning, because most of the reasoning will help you understand how it arrived to that particular conclusion. The other, which is the most deterministic part in our system, is the graph. The graph doesn't fundamentally change. If I ask the same question three times about or inquire over the graph, I'll get the same answer. So that acts as long-term memory for the agent and the large language model. So to summarize, we capture all the reasoning that goes as dialogue between the agent when they're participating in problem solving. The other is, given that it's guided by the graph, that brings a degree of certainty to the non-determinism of a typical large language model.
Cool. The second question that we have here is, basically, someone is indicating that they are using one of Quiet's competitors. Are the autonomous agents additive to existing solutions? So I guess basically the point would be, hey, I'm in a contract. I've got a product in the space. Can I leverage these agents in some capacity? And I'll start with you, Chaitin, but I'll kind of spin this away to Tim as well.
That's a great question. It's something that, in fact, Chris and I were discussing about, which is what we call as staging a consumer to use the product without unpending the prior product that they have. Today, at the moment, given, like I mentioned, I'm sorry about that, an emergency. So if I come back to the question, right, the determinism of the graph is guiding the large language model to make effective recommendations. So if I take the graph away, you're dealing with non-determinism. And most of the vendors today are operating without a graph. And I just want to be clear about that. They speak of context, they speak of everything else, but they're just serving up your code to the large language model and making it reason. So your likelihood of hallucinations from a security standpoint are fairly high. It might do a great job at code completion, but security detection, not so much. But what we will do is try to configure the agents so that it works in coherence with your existing setup. But the goal is to gradually move you to the graph.
All right. So, Tim, the way I would characterize this question to you is you've got a new solution, or I'm sorry, you've got an existing solution. Put yourself in the shoes of a CISO, AppSec leader, CTO. What is your level of interest in having an AppSec platform that maybe does not have this agentic approach, but would you be, you hear a lot about consolidation, less vendors, et cetera. What would be your appetite to go to someone else to go get some solutions like this?
It would be up there. Like I definitely would consider it because I think ultimately when you look at some of the standard tools, I don't want to throw any competitors under the mud, but you're still going to have a lot of work to be able to look through the results, right? And so I think if you're not looking at something that has an agentic AI based approach, I think you're probably still just you're behind. And so from a CISO, from a security leader perspective, I would be open for it, and I would be looking for ways of how can this save my team time, how can we be more efficient with our time, how can we get our product to market quicker, which is ultimately what we're all after because we want to make money with our products. So I definitely would be open to it because I think that a lot of the existing products on the market don't have they're not as forward leaning. They don't have the agentic approach, and so you're left behind a little bit, and you're still struggling with the same AppSec problems.
Sure. Okay. Well, I think this is a good spot to put a pin in things. We have some other questions. We'll get them answered through social media and all that stuff. So first of all, thank you both. I think that we're entering into probably the most innovative time for application security. I mentioned, and I'll reiterate it, I think I'm proud of our industry in AppSec, whether it's us or even our competitors. I think we are all investing in trying to bend that curve, right? I think that the big players are innovating. We're seeing a tremendous amount of activity in the startups, and so it's just everyone sees the need to bend that curve. Everyone sees the need to really provide solutions both to security as well as developers. And I'm really excited for what the future holds. So thank you, Chaden, thank you, Tim, and thank you all who joined us. And we have a third session that's coming up in the new year. And so we hope everyone joins that one as well. Thank you all.
Awesome. Thank you all.
Thanks.